We started our storage module learning about hierarchy of memory. We learned that to work with data, we needed to be in the main memory. However, main memory is expensive and volatile. Therefore, we store data on disk and load it in memory in smaller volumes to work with it when we need it. This is what we do in disk-oriented database management systems, and it affects speed of access to data and therefore the database management system's performance. Buffer Manager works to bring records from the disk into the main memory when necessary. And Disk Space Manager maintains disk space and the tasks such as where to write data on disk. These system components maintain moving the needed data to main memory from the disk when the size of data is larger than it could be fit into the main memory, as well as writing them back to the disk with changes that have been made on them while in the main memory. Also, as we discussed in Module 1, we will learn in the upcoming modules in this course how to optimize data storage and plan and improve our query processing given the fact that we need to bring our data from disk to memory to execute our query plan. We will also discuss how to persist data and maintain the asset properties of data given the characteristics of working with data on storage. This includes our discussion of indexing, concurrency control, and recovery manager components that closely work with the disk management components of our system. This is disk-oriented database management systems architecture. A research performed in 2008 shows that the amount of useful work resulting in the final needs of working with data in a disk-oriented database management system is about 7%. The rest of the system resources are spent on working details of the database management system. Buffer Manager, with 35%, has the highest percentage in the required tasks. The responsibility of the Buffer Manager is to maintain bringing pages from disk to main memory and manage the comparably smaller main memory capacity so that we can have access to the data required in the main memory when needed. This involves using algorithms like LRU or clock replacement to replace the pages that are no longer in use with those that are needed and are going to be used in the future. With increase in the capacity of memory storage, it is possible to maintain the entire database in memory to achieve high performance when required. This is not always possible, but is possible in many cases. This will eliminate some of the system-intensive background tasks, such as buffer management, that are required in disk-oriented database management systems. In memory database management systems, records reside in the main memory. Therefore, working with the database entries does not need access to pages through a buffer pool. This eliminates a level of indirection on every record access and makes it a lot faster. Logging, locking, and latching, that we will learn about later, could also be handled differently for an in-memory database. In-memory database management systems are discussed since 1980s and are available since 1990s. Since the database resides in memory, their access time could be orders of magnitude less than disk-oriented database management systems. They can use alternate solutions to persist their data and maintain asset properties in ways that may not follow the block-oriented access nature of disk-oriented database management systems and the indirections included in CPU access to disk-oriented data. In-memory databases organize data differently. Query processing, concurrency control, and logging and recovery are still applicable concepts for in-memory database management systems, but they are handled differently. Indexes can be rebuilt and updated more frequently. and are not stored in index files on disk. Query processing happens while all data resides in the main memory and will not need to plan for sequential versus random reads from disk to enhance access performance. Logging and recovery will change, as there will be no dirty pages to write or maintain, and checkpointing methods will also be different. Data persistence approaches are also different and may rely on non-volatile memory, which provides persistent storage that is as fast as RAM. Therefore, it is important to note that our discussions throughout this course are focused on disk-oriented database management systems. However, if you're interested to explore, here's a good list of resources to start from.